Writing code to get a job done is one aspect of software development. I'm sure you've all heard of you're doing it wrong, or that's not the right way of doing that. There's no definitive manual on writing software. Sure, there are books full of opinions, ideas, and suggestions. A lot of the books come from years and years of experience actually writing code. I'm not trying to write a book. I'm not trying to make a software development manual. What I'm going to share today is just why I might use a technology over an alternative pattern. The technology in question is Mediator, an implementation of the Mediator Pattern. We'll go into that more later. So we're going to get started with our to-do application. Now, I've done some of the groundwork here. I've created a database service and configured that already. If you're interested in knowing more about how that works, you're more than welcome to go and check out the code in the TBD Friends repository along with the video. So let's start the application as we might write one. So we're going to create a post endpoint. Now the post endpoint is going to be for creating our to-dos, and we're going to start with an empty endpoint. With our endpoint mapped, we might inject our DB context factory, include those references, and in here we might say using var context equals factory dot create DB context, and now in here we can do to-dos to add new to-do, and we can create title equals test, description equals description, and added equals DTC now. Okay, and then we can context.save changes. There we go. So we can do something like that, and let's go and verify we can add that. Okay, so we can run this, go over to our API tool, and we can just post to the endpoint, get back OK, then go back to Rider here, open the database. Now Rider does offer the ability to open SQLite databases in here, and we can expand our tables, and there's our to-dos, and there's our to-do. So that's nice and simple. So we're going to create a simple to-do input model here, and let's take the model dot title model dot description from that model. Now let's run the application again. Now actually send the body here. So let's go here. We can do title equals my first to do, and our description is going to be to do. Right? We want to make it nice and simple. We want to make sure we're seeing what we expect. Now when we post that, we should get back at 200 OK. We go over here, we go to our to-dos, refresh, and there we go. Now we're entering to-dos from the post form. Okay, so now we have a to-do being created. We're posting in that body. Let's go and create the update of that to-do. We've got our structure, we pass in our factory, we pass in our model, we pass in our ID. The ID comes from the route. Let's put this in. So now we have our context. We go find our to-do by its ID. This is a method within Entity Framework. And then we can go and return not found if it's null. Otherwise, we go and update the to-do. So let's save that and run this. So here we have our update to do. We're going to put to this URL, and we're going to pass this object up, and we hit send. We have OK. If we go back over to our application, we go to our to-dos, then we can see update to do, my new to do. Prove that's working. It's not magic. My first to do. Close that. Refresh that. My first to do. So there we go. Okay. So we can now create a to do, and we can update it to do. And you can start to see that this code is actually starting to become pretty unwieldy overall. So if we introduce another method, we introduce our map delete, for example, we go and put our code in here, we go and get our context again, we go and get our to-dos, we then delete it if it exists. And if we run that again, okay, so we now go over to our tool, we have our delete method, we can call delete, we hit send, and we now go back and check our database again, and to-do one has disappeared. So you can start to see that we've now started to build quite a lot of logic in our application here. So what's the evolution of this? So first what we're going to do is we're going to move our input model. I refer to these as input models purely to indicate that they are models coming into the API, right? They are purely made for transferring data in. I just refer to them as input models. That is not a standard I've seen anywhere. I just refer to them as input models. So let's create a models folder here just to keep this clean. And let's create our input model in here. Do input model. Okay. Our program will have some issues with that, but that's okay. We can fix that easily. And now let's go and think about what we want to do with our service. So we need to do public void add to do, right? Because we need our model coming in, and we need a public void update to do, right? So this is going to be an int ID and a to do input model. You can see Copilot is helping me along quite fine here. And we can do the same for delete, right? So now we've got add, update, and to do. Add, update, and delete, sorry. Let's move the logic from here and put that in our service. Okay, so this needs this imported, but now that's working fine. And let's go back to our program. And we can take the code from here. And we can get that into the service. Okay, we'll come back to this in a second. And we can take our delete. We can move that there. So the difference between the add and the updates and the deletes is they return a result. So let's go and make this return a result, right? So we start to have an issue immediately because this is an HTTP result, but our service takes this away from HTTP. So do we just copy that through? Do we return Boolean? What do we do? Well, for now, I'm going to return Boolean. That's kind of beyond what I really want to cover in this video. And that could take us down a deep hole. So we're going to do return false. We're going to do return true. Return true. And again, we're going to do return false and return true. Right? So now if we go back over here, we've got empty code again. So let's go and make sure we can add our service. So our service needs to be injected. So we do need dependency injection here. And we're going to add a transient service of to-do service. Right? Actually, let's add it as scoped for now. So scoped is it will live for the lifetime of the request. Transient is it will be created as it's needed. And singleton will be, it'll be created once per application. So now our from services here, we're going to inject our to-do service, right? And we're going to do service.add-to-do model, right? And we're going to take our from services here. And again, we're going to replace this with a to-do service. And we're going to do return service.update-to-do with our ID and our model, right? And then we do results.OK, results.not found. Okay, and it's going to let me collapse that down so it's a little bit more readable. You know, you can start to see this is getting clumped together, etc. With the formatting, but that's okay. And then we can make one more change to our delete. Okay. To do service. And then here, again, we can do let Copilot fill that in for us in the name of time. So now we have our API store. Remove EF core from here, use our data. So let's go and validate that that's actually working. Okay, so we can add a to-do. So this is going to be next to-do. Should make sure that our service is working. That's our to-do. Okay, so we send that. It works there. Let's go and validate it actually deleted it. Sorry, it actually created our to-do. There we go, number 3, next to-do. It's got our content. Let's go and update number 3. So update number 3 with, and we can send that again. We can refresh that again. There we go. Then finally we can delete number 3. Okay. number 3 is gone. So that's a minimal API. We put the functionality in the API to begin with, and then we moved it out into a service object. So the service object allows us to put that functionality together. It allows us to keep the code a little bit cleaner. It allows us to make clear methods as to what we're doing. And it also allows reuse. We could actually inject this into something else now, and this service would be just as usable because we've got rid of those HTTP concerns. All we have is our DB context factory, and we talk to the database, we get our connections, and we do the things. Some samples will show that code in here, and this is the next evolution of the step. So now what I'm going to do is I'm going to create the same application again, this time using Mediator to identify how Mediator makes this a little bit cleaner. Okay, so let's get started with our Mediator version of the application. So I've started with copying the endpoints from our previous application and just removing the pieces I don't need for right this second. So again, we pass in the body for the model, we update the route, the ID, the delete, etc. And we're going to implement the same actions. So let's get started with that. So I'm going to go into my NuGet package manager. I'm going to look for Mediator. Now, you'll see there's a lot of different libraries out here with Mediator in them. Mediator is a pattern, and we'll cover that again at the end of the video. But Mediator is a pattern first. There are libraries, namely the two that I have used are Mediator, this one here, Mediator, and Mediator. This one actually here, not this one here. They're generally implementations of the same pattern. Mediator and Mediator, the two that I'm specifically going to focus on today, Mediator here and Mediator here, they are almost functionally compatible, right? In terms of if you are using one, you can swap to the other. There are some differences, and that's not really the focus of this video. But I have switched from using Mediator to using Mediator this year. I feel that it's a stronger path for me going forward with my applications, but they are both very functional, and the authors of these libraries fully understand the pattern and have put a lot of work into authoring them. So no matter which one you go with, you're not going to be sent wrong. So for the purpose of this, I'm going to use two libraries for this Mediator library. I'm going to use the abstractions and the source generator. Okay, we're going to introduce them. And then what I'm going to do is I'm going to, for the purpose of this demonstration, I'm going to create everything in the same class library, in the same application. That's just because it gets noisier if I start creating extra class libraries and moving things around, etc. And for the purpose of being able to read this code back, it'll be simpler if it's all in one place for you, the viewer. However, in an actual application, you would probably break these up into actual class libraries to increase that maintainability, improve that reusability, and keep all your things separate. General architecture is not the purpose of this video. So let's start with. So I'm going to start with a folder called commands. This commands folder is going to receive all the things that I want to put in there, such as add, update, and delete in this case. The Mediator pattern is one of sending a command to a handler, and that is the core of it. There's a lot more involved in the libraries themselves. The idea is you say, hey, I want to do this, or I want this, get this, etc. Commands and queries, I'm going to start with adding commands, right? So let's go and add our first command. Now, there's a couple of standards of doing this, and I'm going to cover one here. And it's one that I favor because it adds to readability. So what we're going to do is we're going to do add do, right? There is a way of laying this code out in such a way that it makes it a little bit more readable, in my opinion. It does add more bloat to files. So what we can do here is we can say, okay, well, we're adding a to-do, so to-do has public string title, a to-do has public string description, and there we go. Let's add a to-do, right? And now we have an add to-do handler, right? And in here, this will handle that command. But I don't like this bloat, so I'm not even going to write the code here, right? I'm going to demonstrate the way I would normally do. It's actually a recommendation of Jimmy Bogard to combine these two things, because the command and the handler never really live apart. You don't say, hey, in dependency injection, if it's a Tuesday, go to this handler versus this handler for the same command. They are always linked together. You're really saying, hey, invoke this handler. You're just doing it in a different. So I'm going to remove this handler class here because I kind of like this pattern. What I'm going to do here is I'm going to create a public record command. And it's going to take a title and description, and it's going to be an I command, which is an interface defined in the Mediator library. Also in here, I'm going to create another class called the handler. This handler is going to inject our IDB context factory of to-do DB context, right? And this handler itself is going to be an I command handler of command. Okay, this is actually trying to return something here. So, okay, now this handler needs implementing. So let's implement that handler. And what this is going to do is going to say handle this command, right? In here, we're going to do the code we did before, var. Okay, so we have our add to do. We have a command and handler paired together. Okay, so we've added our command, we've added our handler, now we've implemented our code, we've got our add to do command. If we go back over to our program now, we need to inject something to get that command to be sent. So what we do is we do from services, we need an I sender, right? You send commands within Mediator, okay? And then simply in here, we do sender.send, and we need a new add to do. Now this is where this does create a slightly weirder pattern in that we have an add to do.command, but it does allow us to read that. That's in our command with our title and description, okay? We do need to do a little bit more setup. We need to do, say, builder.services.add mediator. There we go. Okay, so with our mediator injected, our sender injected rather, I mean, you can inject, so for reference, you can inject an iMediator here, right? I could call that mediator, and it does, iMediator is iSender. iSender is a very specific interface just to say I am sending, right? There is an iPublisher interface, which is again beyond the context of this video, but iPublish allows you to publish notifications so you could receive it from many different handlers, right? So events in your system you could use iPublisher for. So I like to be specific here and I am using iSender. So let's go and try and run this now. So we should be able to add. So here we are. We're going to post to our new API. To do. Okay, let's go back here and open our database as before. Again, Spider does have the tools built in for that. And that's to do. That's our previous one. Here's our new one. Go to our tables. We can go to our tables, and there to make sure Mediator is working. Let's stop running. Go back to our code. So at this point, I think you can tell where this is going to head. But let's continue on and add in the rest of the functionality. So we're going to create an update to do. Our update to do needs a command again. This time, we're going to use a record. A record is a simple object to use here. You don't need you could use a class. It doesn't really matter. It's a simple data transfer object used to pass this data from your API through to or not necessarily your API. It could be another application. It could be whatever you want to use it in. But it's to pass the data from one thing into your handler. And it's, because we've got it nested under update to do, it's easier to call it command. If we wanted to break this out, we could have add to do command and add to do handler as classes, and update to do command and update to do handler as classes. This just makes a very clean way of reading this, and you can see it. From a folder structure perspective, you are reading what it is you're doing. You don't care about command and handler specifically, and your standard is that. So you can do it however you like, but this is how I do it, and I kind of prefer it. It just makes readability. So I'm going to let Copilot do its thing there. I'm going to add that mediator, and then let's let it fill itself out a little bit, right? So Copilot is just helping me along here. Now let's inject our context factory as before. We're going to do DB context is our factory, and then just the same as before, we're going to use context equals factory.create DB context. We're going to get our to do, bar to do equals context.todos.find. We use our command.id this time. If to do is null, so in this instance we don't have a return type, but now we need a return type because we should do something based upon the result of this. So let's go here, and we'll do it the same way we did our service, right? We returned a boolean in our service. Again, there is different patterns here. There's you can use result libraries, etc., to return an actual state. But for the simplicity of this application, I'm going to stick with some simple types. So we can return false. Okay, so by returning a boolean, we've introduced a new challenge to this. In the add, it didn't need to be asynchronous, or it didn't need any of the task-based behavior. So if you look at the add, you'll see that I return value task, unit value task. That's just a task that will complete, and this can still be run asynchronously by the piece that runs it, but it doesn't need any asynchronous code in here. So I didn't do anything specific here. Because I'm returning a type here, I'm going to need to do something, otherwise it's not going to like this because it's not returning a value task of bool. So I'm going to cheat a little bit to make sure that I can just return a boolean here. First, I'm going to make this async, okay? And then instead of create DB context, I'm going to create DB context async. I'm going to await that, right? Now it wants the cancellation token because I've opened up a can of worms here, right? And now it probably wants me to make that async, right? Because once you go async, it's a little hard to do. And now I'm going to have to await that one as well, right? But now I can return false and everything still functions. So I'm going to leave it as that. It is offering a green squiggle here. So what it wants me to do here is tidy this up a little bit. So it wants me to do an await using on there. And the green squiggle here is, again, I can make it using declaration and kind of improve the nesting, which I would recommend. I've been using the nesting for the purpose of visibility in the demonstrations so far, but it's not really harmful. And again, now we need to update our to-do, right? Now we need to save our changes. And again, because I've asynced one thing, it's going to want to async everything else. And now we can return true. Okay. So we have our update. We send in our command into our handler. Let's go and implement the code on the API side. And then you can do sender.send new update to do dot command. And this is going to take the ID and the title, the model.title and model.description. We return a result in this. And this is where this gets a little harder, right? So I need this to have a result, but it's asynchronous. So is this going to return? It's going to return a value task, not the actual result. So I need to await this result again, right? It will determine the result based upon this command, right? This command is an I command of bool, so it knows it will get a bool back when it awaits it. But I need to await it now. So I need to make this async, and I need to await that. So var result equals await, okay? And then we can do that, okay? So now we have result equals await sender.send, our command. So I think you can guess where the delete goes from here. Go here, add a new command, delete to do, and it wants to implement it for me. So I'm just going to let it in this case, just for the sake of the video, and we can do that. Okay, so again, the delete is the same pattern. We're going to find it. We're going to check to see if it's null. If it is, we're just going to return false. And if we can, we're going to remove it and then save. Okay, we can go over to our program here and we can implement that code. So, okay, we've implemented our delete. We are going to await the sender.send of a delete, and then we're going to return based upon whether we get a successful delete. So at this point, it's just testing. So let's go and validate things. We go to our add again. Let's validate that our add still functions. We can do our next to do. Okay. Go here. Let's go back and check our database rather than just assuming that it's going to work. And we can see we have our next to do. So number 2 is our next to do. Let's update number 2 and we can send that. We validate that that update happened. Now we can go to our delete and we can say we don't want to delete number 2. We hit send and number 2 is gone. So what do we do differently here? Well, our code, our API code looks a little bit more complicated now because we've got our awaits and whatnot in there. But overall, it's doing the same thing as the service, right? The service was a way of taking the code from the front end, the front end being the API, the entry point of the application, right? But taking that code out of our API endpoints, moving that behavior into the service did give us the ability to test it, maybe to keep the concerns wrapped up into this nice thing called a to-do service, right? My fear of using things like services is that they become dumping grounds, right? When something, and it's my same fear with controllers and things like that. If you start putting behaviors into this class is just a placeholder for everything that might be related to that thing, right? So the to-do service, if I have, notify me of when a to-do is scheduled, or whatever, or notify me when I've completed a to-do, etc. Those actions might end up getting put into the to-do service because the to-do service is this all-encompassing thing. So it does keep things cleaner to move it up into a service. However, all this behavior will start to grow, and what you could end up with is a many thousand-line file of all these individual methods that do these things. So moving to Mediator, you do gain some readability, right? You can organize your code by its behavior, right? You can name these whatever you want, really, but as long as you are, by breaking those individual actions of the service out into specific commands and handlers, it does allow a greater readability, right? Code is easier to maintain if you can read it and understand it. So the more dependencies you add into the service, the harder it gets to maintain, the harder it is to unit test, because now every unit test has to inject those dependencies. You have to configure them right. If you don't configure them right, maybe the service breaks. Your method might not even use 50% of those dependencies, but a method 1,500 lines down into the service does. So services can quickly get out of hand. Using Mediator, we can simply send commands into our application layer. Our application has a very specific task. Here's the thing I want to do, right? You try to keep these clean. You try to keep these focused on the task they're actually being told to do. There is a perceived anti-pattern here of injecting an I-sender into this, right? So if you want a Mediator command to send other commands, there is a perceived weakness there. And I'm not sure whether I totally disagree with it, but it's something I try not to do, right? I try to hold pretty hard to that rule. This normally comes into play when you're trying to say, hey, well, I need to create X, Y, Z, etc. Based upon this one command. So that's when that will normally trip you up. And I don't think, as long as you understand why it's doing it and what it's doing, it's necessarily a bad thing. It's not prevented. It's more, you have to ask yourself the question, should I? So there we go. There's our Mediator. We have our add, our delete, and our update. We can read them from code. We can go straight to what we need. Again, this code wouldn't live in this application. Normally, this would live in its own library. That is our Mediator. I like using Mediator because it allows me to break up my application into relevant chunks without harping on it again. The services do end up being clumped together pretty quickly, and your application can grow out of hand. And I've experienced that. When you've started to use Mediator, the patterns start to make sense. The usages start to make sense. You can look into CQRS, command query responsibility segregation, allowing you to send commands into your application and also send queries using the same thing. You don't have to just tell the system to do something with a command. You can also use it for queries. And Mediator itself does actually have iCommand and iQuery interfaces, but I felt it was a little bit beyond this video. So hopefully this has been fun. Thank you very much for joining me. Please don't forget to like, share, and subscribe, and I'll see you next time. Thank you.